Good morning, class. This is Mr. Casabona again speaking. Today, I would like to talk to you all about the universe and the galaxies, sometimes referred to as the field of cosmology. As we begin, I want you to ask yourself one question. How was the universe formed and what is it composed of? I'd like for this question to just linger in your mind as we go through these next few lectures. I'd first like to take a poll and ask you a very simple question. How much do you already know about the universe and galaxies? A lot, a little, or nothing at all? It's okay. Just be honest. This is just for your own reference and my reference of what you may have already known. Now, for those of you that know something, I'd like to know what that is. So I'd like to give you a moment. Just write down what you already know. I see an answer already. Student A says that the universe has everything in it. And that's true. That's probably the most basic definition we have of the universe is that it's just everything. Now, the first place to start when talking about the universe is how it began. And that takes us to the beginning. In the beginning, we believe that the universe was condensed down to a single point, and that in a moment it just expanded in a massive fiery explosion that we refer to as the Big Bang. So the Big Bang theory tells us that the universe started in this explosion about 13.8 billion years ago, down from one single spot, one single point in space to everything that we can see in the night sky and beyond. After the explosion, and for eons later, the universe was so hot that nothing could form. It was just energy. It was just energy and other funky forms of matter. And it wasn't until the universe started to cool down that we started to see the formation of what we call subatomic particles. So the three basic ones are protons, neutrons, and electrons. And as the universe cooled further, these subatomic particles would get together to form what we call atoms. So we have the nucleus, the protons and neutrons, with the electrons orbiting around. On the next slide, I'd like for you to watch this video and take notes on some of the interesting things that you learned. Great. Now let's ask another question. What specific evidence supports the Big Bang Theory from the video that you just watched? Okay, good. Student B says that we can see that the galaxies are moving away from each other. And that's true. That's actually the most basic evidence that we have of the Big Bang is that everything is still moving away from each other. Kind of like the explosion is kind of still happening. Very good. Now, the universe is composed of a bunch of galaxies. And when I say a bunch, I mean like another hundreds of billions of galaxies. Now, what is a galaxy? Galaxy is a collection of gas, dust, and stars. Stars, we all know. We all know the sun, and you can see many stars when you look out at night. Dust and gas, we don't really see too well unless you have very specific kinds of telescopes, but they're just either clouds of gas, mostly of hydrogen and helium, or dust, which is just like granular particles that are kind of just floating around in space. And all of this together forms the structure of a galaxy, which is held by gravity. Now, we don't know for sure an exact number, but it's predicted that that galaxies can have hundreds of billions of stars and that there are hundreds of billions of galaxies in the universe. And these galaxies are typically categorized by their shape. And the three basic ones are spiral, elliptical, and irregular. On this next slide, I want you to watch this video and you'll learn some more about this and just take notes on some of the more interesting things that you learn. All right, bringing it back now. I'd like to know what are some of the different sizes and shapes of the galaxies from this video. Okay, good. Yeah, student C says spiral. Spiral is it kind of looks like it has legs orbiting around the center. You have the elliptical, which is a disc, a frisbee, very good, like a stretched out frisbee, and irregular that just kind of doesn't have a real shape. It seems unorganized, but it's still being held together by gravity. Very good. And these varying shapes as well. We typically see spiral galaxies can be much larger than, let's say, the regular kinds. Very good. Now, for the next section, we're not going to be able to finish this, but just to get started, let's talk about our own galaxy, the Milky Way. The Milky Way is a large barred spiral galaxy. So you have the spirals going off, but in the center, it seems like one giant bar, which is really good evidence that our galaxy has interacted with other galaxies, which we saw in the video. We saw that it's very much possible that we've been interacting with neighboring galaxies for billions of years. Galaxies is so big, in fact, that it would take light 1.6 million years to go across the entire diameter. So it's 1.6 million light years across. And you can, in fact, see it. So before the next lecture, I want you to go out, look at the night sky, and depending on light pollution, you might be able to see a white band across the sky. And that band is actually the plane of the Milky Way, because you're looking through all of those billions of stars that just kind of seem like they're clumped together into one large band, but in fact they're just a lot of stars. So I'll leave you at that, and I look forward to seeing you in the next lecture. Thank you.